this lesson, we're going to be talking about finding solutions of polynomials by factoring, and also we'll be doing some graphing, and we will write polynomials given factors. So first of all, the definition of factors would be that it is one of two or more numbers in algebraic expressions or the like that when multiplied together produce a given product. So 12 times 5 equals 60. So we would call 12 and 5 the factors, and 60 would be the product. One thing to always keep in mind here in this chapter is that factors divide evenly into a product. The remainder is 0. So 5 goes into 60. If we do long division, first we divide, and then we multiply, and then we subtract. 6 minus 5 is 1, and then we'll bring down the 0. Now we start over again with the algorithm. We divide. 5 into 10 is 2. Multiply, you get 10. Subtract, we have 0. So 5 goes into 60 12 times, there's no remainder. And 12 goes into 60 5 times. And then divide, multiply, subtract, and the remainder is 0. Here's an example of a polynomial y equals x squared plus x minus 6. The factors, if we were to factor that polynomial, would be x plus 3, x minus 2. So we would say that x plus 3 and x minus 2 are factors. If we FOILed those back together, multiplied them back together, it would equal x squared plus x minus 6. That is the product. And then remember too that we learned that we can find the solutions or your x-intercepts by setting y equal to 0. And then we would set each factor equal to 0 using the 0 product property. And that would show that x has a, if we solve that, x would equal negative 3. Set x minus 2 equal to 0, x equals 2. And those are your x-intercepts, and we would call those the solutions. So we can use solutions, or the zeros, which are the zeros, that's another word for solutions, to graph. And so if we set y equal to 0, we would set each factor equal to 0 to find the x-intercept. So x would equal a negative 2. So at negative 2, we can put an intercept. X minus 1 equals 0, x equals 1, that is a solution. And then x minus 3 equals 0, so x equals 3 is a solution. Now, once you get used to working with these, you don't need to multiply this all out. You can just multiply the first times the first times the first, so that would be x to the third. And then you would see what the end behavior is, but let me just show you how that works. So if we have the polynomial x plus 2 times x minus 1 times x minus 3, and we want to multiply those factors out. First, we would multiply the first two factors together. So we would FOIL that. X times x is x squared minus 1x. The inner would be plus 2x. And then 2 times negative 1 is a negative 2. Before I multiply again, I'm going to combine the like terms. Minus 1x plus 2x is 1x minus 2. Now we have to multiply that times x minus 3, so we'll double distribute. First, we're going to distribute the x through everything. So that would be x to the third plus x squared minus 2x. And then we'll distribute the negative 3 through. And that means, when I say distribute, again, I mean multiply. So minus 3x squared minus 3x plus 6. That gives us x cubed. Let's combine like terms here. That would be negative 2x squared. Minus 2x and minus 3x is minus 5x and plus 6. So the multiplied version, or the multiplied out form, the polynomial, is x cubed minus 2x squared minus 5x plus 6. So if we look at what we learned from the last section about end behavior, this is an odd, which means it's either an up-down or a down-up, and the leading coefficient is positive. So it's going to look like this, like a positive slope. So it's going to be going down as x approaches negative infinity, and it's going to be increasing as x approaches positive infinity. So because of that, we can go ahead and say this is going to be going down as x is decreasing. As x is increasing, this will be going up. Now, we have to just figure out what's happening in the middle. So to do that, we'll make an XY chart and just plug in some of those values between the intercepts. So -1 we'll plug in, 0, and then 2. So if we plug -1 in, I'm going to plug it into each of these here. So y equals x plus 2 times x minus 1 times x minus 3. So if we substitute in -1, that would be -1 plus 2 is 1. -1 minus 1 is a minus 2. -1 minus 3 is a minus 4. That gives us a positive 8. So -1, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like that's going to be a maximum value probably. And now we'll substitute in a 0. So we would have 0 plus 2, that would give us 2. 0 minus 1 is a -1, and 0 minus 3 is a -3. That gives us -2 times -3, that's a positive 6. So what this graph is doing is going like this, and now let's substitute in the 2. So 2 plus 2 is 4. 2 minus 1 is 1, and 2 minus 3 is a -1. So that will give us a -4. And there is our graph. All right, this next problem says write the polynomials in factored form. So first thing we always want to do when we're factoring is look for the greatest common factor. If there is a greatest common factor that we can factor out. And here we have an x in each that we can factor out. So that would leave us with x squared minus 2x. We're taking an x out of each. When I say taking it out, I mean we're dividing it out. And then minus 15. And when we're factoring, we factor until we can't factor anymore. So this is a trinomial that will factor into two binomials. Now, we want to have the factors of 15 that have a difference of 2. So it's either 1 times 15 or 3 times 5. So it looks like 3 and 5 is what we would use. And let's see, if we have a positive 3 and a minus 5, that would give us negative 2. So when we multiply this back together, this has to equal this. So x squared minus 5x minus 3x gives us the minus 2. And then 3 times negative 5 gives us the negative 15. So those are the factors. Here we'll do another one. Again, we can take an x out of everything. And now we'll factor the trinomial. So x times x is x squared. The factors of 12 that have a difference of 1 would be 3 and 4. And we want to have a difference of negative 1. So we want minus 4 plus 3. That would give us a negative 1x in the middle. And we'll just do one more here. Let's take an x out of everything here. So we would have x squared minus 4x minus 21. And so we have x times x. The factors of 21 that have a difference of 4 would be 7 and 3. So minus 7 plus 3. Minus 7 plus 3 gives us a negative 4. Now we are going to work the other direction. It says, what are the solutions here? Well, the solutions are x equals 1 and x equals 3. And if we want to get 0 on one side, if we want to get the factor, what we would do is we would subtract 1. So x minus 1 would equal 0. So that would be a factor. X minus 3 then would equal 0. So that is another factor. It says, what would be the equation of the function? Well, if these are the two solutions, these are the two factors, to find the equation, we would multiply the factors together. So we're just working backwards. So we then have x squared minus 3x minus 1x. So first times first, outer times outer, inner times inner, and then the last times the last is plus 3. Combine like terms. And there is your function. So we could say y equals x squared minus 4x plus 3. What is a cubic polynomial function in standard form with zeros negative 2, 2, and 3? So if the zeros are minus 2, 2, and 3, the factors have to be x plus 2, x minus 2, and x minus 3. And so to write the polynomial function, we just have to multiply these together. So we're going to multiply the first binomials together, and we'll use that FOIL process. So first times first is x squared. The outer is minus 2x. The inner is plus 2x. So those cancel. And then you have minus 4. And then we have to multiply that by x minus 3. So you notice this was the difference of two squares, so you didn't have that middle term. So now we're going to FOIL again. So first would be x to the third. The outer is minus 3x squared. The inner is minus 4x. And the last term times the last term is plus 12. And there we have our function. We can call it y, or we could call it f of x. And it says, what is a quartic polynomial function in standard form with the zeros negative 2, negative 2, 2, and 3? So the first, if x equals negative 2, one of the factors would be x plus 2. The next one would be x plus 2. Then we have x minus 2 and x minus 3. And we're going to multiply this all together. We're just going to take a couple at a time here. So first we'll FOIL those together. That would be x squared. And then the outer is 2x and the inner is 4x, or 2x, excuse me. So that gives us 4x altogether. And then plus 4. So 2x and 2x is 4x. 2 times 2 is 4. Now we're going to multiply that times x minus 2. So we have to double distribute. So we'll first distribute x through. So multiply everything through by an x. And then we're going to multiply the negative 2 through. So that would be negative 2x squared minus 8x minus 8. And let's just combine like terms here. So that's x cubed. 4x squared minus 2x squared is 2x squared. 4x minus 8x is minus 4x minus 8. All right, so that is multiplying the first three together. Now we still have to multiply all of that by x minus 3. So again, we will double distribute. First, distribute the x through to everything. Okay, x to the fourth, that would be x. Let's see, let me see here. 2x, this should have been a 2x squared. Let's see, 4x squared minus 2x squared would be 2x squared. So I knew I had to have an x cubed here. What did I do? X to the third, x squared. Okay, yes, so x times x squared is x to the third. And then we have x times minus 4x, that'd be minus 4x squared, minus 8x. And now we'll distribute negative 3 through everything. So negative 3x to the third minus 6x squared plus 12x plus 24. And combine like terms. So we have x to the fourth. 2x cubed minus 3x cubed is minus 1x cubed. I'm going to cross these out because this is a little bit long. Minus 4x squared minus 6x squared would be minus 10x squared. And then minus 8 plus 12 would be 4x. And plus 24. There we go. There's your function there. Now we're going to find the zeros of each function and then graph it. So to find the zeros, you set each factor equal to 0. So x minus 1 equals 0, x equals 1, x minus plus 2 equals 0, x equals negative 2. So 1 and negative 2. And we just need some more points. So first of all, if we multiply the first times the first, the leading coefficient would be 1. And the degree would be 2 because it would be x times x is x squared. So we know it's positive, so it will be an up-up behavior. And so now we just need to plug in a point, and I would say, let's see, the middle is about negative 0.5. Like if we made an XY chart, we could just start plugging in numbers. I know the axis of symmetry would be at negative 0.5. So that would give me, let's see, negative 0.5 minus 1 is negative 1.5. And then this would be negative 0.5 plus 2 would be 1.5. So that gives us a negative 2.25. So right about there. So that's how that's going to look. In the next problem, we will find the zeros. So this is going to be a negative 1, a positive 2, and a positive 3 if we set each of those equal to 0. And when we look at what our end behavior would be, basically you're going to end up taking x times x, which would be 1x to the third. So it's odd, so it is an up, down, or down, up. And it's positive in front, so it's going to have like a positive slope. So this end is down, this end is up. And now we will make an XY chart and just plug in the values between. So we'll plug in 0, 1, 0, 1. Let's see, so if we plug in 0, we would have 1 times a minus 2 times a minus 3. That gives us 6. And if we plug in 1, we would have 2 times a minus 1 times a minus 2. That would be 2 times 2 is 4. That'd be a positive 4. So we're going to go like this. And we know this is going to have to come down a little bit. You could plug in a point, or you can just kind of estimate what it would do there. And in this, here's an example of a problem you will do in your homework. It says find the zeros of each function. So really, this means when it's x plus 3 quantity cubed, it means x plus 3 times x plus 3 times x plus 3, that quantity. And so if you set each of those equal to 0, x would equal 3 in all 3 cases. So that would be your solution. Next, it says find the 0. So when we want to find the zeros, we want to look at the polynomials in factored form. So you want to factor this. And there is an x term in each, so we're going to first factor that out. And x divided by x is 1, so don't forget that. So now that's a trinomial. We'll factor it into a binomial. So 2x times x gives us 2x squared. 1 times 1 gives us 1. And we want to have a positive 1x. So what we would want is a positive 2x minus 1x. 2 minus 1 gives us the 1 in the middle. So this is factored form. So your zeros then, if we set this equal to 0, x would equal 0. 2x minus 1 equals 0, and x plus 1 equals 0. So x equals negative 1, x equals 0, and here we have to do a few steps to solve. So we have 2x equals 1, so x equals 1/2. So those are your 3 zeros. So this was x to the third. Notice there are 3 solutions. Here's another one. Let's do this one. Here we can take out a 3 out of both terms, and we can also take an x out. So we would have 3x dividing out, and that would leave us with x squared minus 1. So now what we're going to do is set each factor equal to 0. And you could solve this one by factoring again. This is a difference of 2 squares, so that would be x plus 1, x minus 1. Or we can solve by taking square roots, by bringing 1 to the other side and taking the square root. Remember, when you solve by taking square roots, x would equal here plus or minus 1, because 1 squared gives you 1, and negative 1 times negative 1 gives you 1. And then here, if we divide by 3, x equals 0. So your solutions are x equals 0, and x equals plus 1, and x equals minus 1. And that is that for this lesson. So let me know if you have questions. Thanks for watching.